I am Rick Claus. I am a cloud ops advocate that used to be a senior PM on the Azure Compute engineering team, working in the product group. And I was one of a couple of different folks that had the job. Actually, I was one of a couple of different roles that was all on one head at this point in time, where I was the engineering liaison for Microsoft Azure, talking to Oracle engineers for Oracle Linux, Oracle databases, and how they all work on top of the Azure platform. And yeah, so I made the mistake of answering some questions on internal DLs and support aliases about Oracle on Azure, about licensing, about architectures, and how to do stuff. And then gradually, my inbox started to get fuller and fuller and fuller. And then we got Teams, and then the Teams conversations got more and more and more. So now a lot of the folks that I know out there actually call me, I'm the Oracle of Oracle on Azure. For how things work. So I'm from an engineering background, so I'm not going to candy code anything. I'm going to give you the straight shots about everything. And this was kind of an interesting session I put together just as a pitch to see if anyone would be interested, and it got picked, so apparently it was, to talk about what are the things that I've been seeing over the last couple of years with questions coming up from our customers, from our account teams, and from the online community about how to run Oracle workloads on Azure. I mean, it's a valid workload. Almost everybody has some form of Oracle inside of their environment. And like any complex workload, doesn't matter who the vendor happens to be, any complex workload inside of your data centers, inside of your environment, it's the ones you don't want to touch until the very end of doing other projects, because it's just a whole lot of mess of stuff that you have to go through, and you've got other lower hanging fruit to go forward with. So what I've noticed in the last year or so is that people are now starting to get their table clean, if you will, and they are starting to look at these different workloads and trying to see what makes sense to be able to go off and to use inside of a cloud environment, or keep it on premises, or go with a multi-cloud option, and come up with solutions, and also come up with a lot of questions that need to be answered. So strap in. There's no demos. This was cut down from a 75 down to a 45, and I figured it was more important to answer questions and to answer a lot of the stuff that I've heard than be able to show you some very simplistic demos about Oracle on top of Azure. It's, you know, it's the relational database on Azure for the big part, so no big deal there. So we were having a discussion over here before we started talking about this, and it's like, yes, believe it or not, Oracle and Microsoft have been in a partnership now since 2013. Back when we launched IaaS. And we had a big, huge press release and announcement and sort of stuff that was going out that basically just says, you know what? We are working together for the purposes of ensuring that our customers have a ability to run our workloads across Microsoft Azure in this case, and have the flexibility in how to deploy it. So you can choose to deploy it on premises, you can choose to deploy it on Azure, and we're going to support you. World-class mission-critical software, Oracle being the leading private environment, public cloud platform on Microsoft. Here's a great thing. I'm always going to give you links to public documents, because that's what everyone always wants to have, right? They have to go back and talk to their teams. They have to go back and share this with the different levels of execs that you're working with. So every single one of my quotes and every single one of my references are all going to have links that you'll be able to do. A gentleman down in the far corner, because he's looking for a plug, was looking for the slide deck because it wasn't up there yet. I apologize. I was completely delinquent on my deliverables for having my slides ready in time. So they will become available. This session is being recorded, and you can see it again later, and you'll be able to have the deck at that point in time as well. techcommunity.microsoft.com is going to be where this recording is, and also where the deck will eventually be too. So as I mentioned, that partnership's been around for a while. I was actually involved in a small portion of the technical aspects of how that particular partnership works, because I was part of the engineering team when the renewal came about. But as I mentioned, a lot of this stuff that comes out of this particular session is around the fact that I've been getting a lot of different questions come up through the escalation pipes about asking about these hard questions on how to do things. We're talking data center migrations, data center closures, shuffling stuff around, not wanting to go off and do another major capital acquisition or capital expense to be able to go off and buy new equipment, buy new hardware. What can I do to be able to modernize some of this stuff? And so it was coming up that we're looking at having to move these different workloads up into an Azure environment, but also then go through looking at how to do some modernization of things, and how to go ahead and understand the different security implications. How do I back things up? And what types of stuff can I run on top of Azure? And so all that sort of stuff comes up during this type of discussion. However, I'm wondering if you could probably guess what is the #1 question people ask when they start talking about this kind of subject? What's your number one question here? Just say it, anybody. Oh, look at that. It's my next slide. For some reason, I knew this. I don't know why I knew this. So yes, we can't have an architectural discussion until we actually work out this whole concept of licensing. And I have caveats. No, my legal advice did not tell me to put this in, but this was simply me putting it anyway. Obviously, contracts, make sure you know exactly what's involved with your licensing agreement with Oracle. Make sure you understand that it is a contract. There are legal terms. There are considerations and policies. I am absolutely not a lawyer. I'm absolutely not a licensed authorized specialist to understand this sort of stuff. This is how I've come to understand a lot of the things that have come up in the past. You need to know what your individual licensing terms are. You need to understand what this means. Do you have a EULA in place? What restrictions are in that EULA? EULA stands for Unlimited Licensing Agreement, in case you don't know. I'm assuming you do because you're all here and you all have Oracle software. Unlimited doesn't always necessarily mean unlimited. And finally, know the difference between usage rights and also support of different products. So those are my caveats for what happens to be there. And that kind of brings up one other thing that comes up second to that is this certified or is this supported on top of Azure or other solutions? And so there's a whole page, again, that talks about what exactly is certified to run, what is supported to run. And your friend is the support notes from Oracle. You have to be able to go in with your support contract, do the searches for your different products. But generally speaking, the terms are if it runs on top of Windows Server or Hyper-V inside of the MOS notes, it is a supported product, not certified potentially, but it's a supported product on a best effort basis by your support contract that you happen to have. And that was part of the agreement that Microsoft and Oracle signed in 2013 and then renewed in 2016. So that's, again, the announcement. Inside your support notes, they're the main ones. So what I've always been doing is having to go in and sift through the different MOS notes and find the MTRs, minimum technical requirements. And so if you can meet the MTRs listed for the products you're looking for, and you have something that is able to run on Windows Server or on Hyper-V, you fall within those guidelines. And it's a matter of knowing those different statements, being able to provide some links to be able to have that conversation take place. So, certified and supported. There's a big difference between the two. Just think of it as best effort, right? Best effort. This also comes up because people ask me, well, I want to run Oracle Database 12.2 on top of Red Hat, on top of Azure. What kind of support am I going to get? And it's like, it's going to be best effort basis. You've got to follow exactly what they have inside of the different support notes for how to be able to go off and to run that. And so, to get the elephant in the room out of the way, licensing Oracle products on Azure, when it comes down to it, there's a statement that was published inside of the Oracle website that basically says, when counting Oracle processor license requirements and authorized cloud environments, Azure and AWS are authorized clouds, the Oracle processor core factor table is not applicable for the purposes of licensing Oracle programs and authorized cloud environments, Azure. Customers are required to count as follows: 2 vCPUs as equivalent to 1 Oracle processor license if hyperthreading is enabled. Otherwise, it's a 1-to-1 ratio. And this is probably the most cited and referenced PDF file that I can see people nodding their heads. They probably have seen this before. Right here. That's the one that you need to know for what it is. There are only 2 authorized hyperscale cloud environments to be able to run Oracle on besides Oracle Cloud, and that is AWS and Azure. If you're outside of those, they have different licensing terms, different agreements, different levels of support, just to be completely transparent. So if we evolve that, this was the conversation I was having before we started, with regards to what is the current licensing policy. You have to check the dates. I actually have 4 different versions of that one PDF file that I've been tracking since I started in this role. And there was a bleak time that happened about 1 year and 6 months ago when all of a sudden a single sentence was struck out of that PDF file which says that you could use the core factor table. Because that one single sentence allowed you to basically do a 2-to-1 ratio plus also do a multiply by 0.5 as well for a double discount. So basically that was struck out and removed in January 23rd, 2017. All of a sudden, the tech press went crazy, and it says, licensing costs double if you run it, and blah, blah, blah. So that was a bad day. It stayed in place for about 9 months, or 10 months, and then it finally came around that at that time, we didn't have a hyper-threaded VM. That was a time when we didn't have hyper-threaded VMs available. So we all of a sudden dropped down to a 1-to-1 ratio, which was like almost 4 times the cost. And so now we're back on par. So as an example, for being able to explain this, if you happen to have, before I even start this, put up my disclaimer. For example, if you have an on-premises system, let's say it's a single socket, 8 physical cores, but they're actually hyper-threaded. So you get 16 hyper-threaded cores. You would simply take the hyper-threaded cores, multiply and use the core factor table of 0.5, and that would make it so that you would have to have 8 Oracle core licenses to correctly license that box for running an Oracle database. I'm talking Oracle database here. I'm not going into all the other sort of stuff. Now, in an authorized cloud environment, if you have a 16 vCPU VM, in an authorized cloud environment, you can only use the authorized cloud environment ratio, which is a 2-to-1 ratio, which means that the VM is going to require also 8 Oracle core licenses. It is not 4 times more expensive to run on Azure. That was a very popular press quote that came out a year ago, or twice as expensive to run on top of AWS. So this literally is, we're on par with what it costs on premises. This also does not count if we're talking a unlimited licensing agreement or EULA. That has a separate set of restrictions on if you can transfer them or not, and that's unique to your EULA. But if you're talking licensing, soup to nuts, the basics of core counting, that sort of stuff, are basically the same. And this also is completely separate from how you license Oracle software inside of their own cloud, because it's their own cloud, their own stack, and they're able to do what they would like to do inside their own environment. That's the simplest I've been able to find to explain Oracle licensing on a hyperscale cloud environment. I'm not going to take any questions because it might fill up the rest of the time, so come and see me afterwards, but that essentially is how I keep it as dirt simple as possible for being able to have the conversation around things. So, what workloads are we talking about? Well, primarily, the ones that I get asked all the questions about are normally the back ends and the lower level stuff. So basically, the database back ends that are running. If you run WebLogic, that has database back end. If you run EBS, that has an Oracle database back end, that sort of stuff. Those are separate conversations that absolutely can run because we meet the MTRs, minimum technical requirements. Whether or not they're certified is another question. But they should be supported on a best effort basis. But the back-end database definitely is certified for how it goes off and works. And we have basically images and capabilities of being able to run 12.2 inside of Enterprise and Standard Edition. You also have the ability, obviously, to go off and to run JDS if you wanted to, or JD Edwards, eBusiness Suite, and also WebLogic servers. But those are only because of the gray area of the fact that we meet the MTRs and the fact that they happen to have Oracle database backends. I'll talk about RAC because I know you're all going to be asking about that in like 3 seconds, so just hold on to your questions. Now, the high availability side, because that's where people ask about Oracle RAC. Yes, absolutely. Oracle RAC is not able to be run inside of a hyperscale cloud environment, with the exception of running inside of OCI, Oracle Cloud, because of some physical requirements that have to be in place. Oracle RAC is a technology that's designed for inside of a data center, super fast connectivity, shared networking, and shared disk. It's clustering software, right? So you don't have that in a hyperscale cloud. You don't have the ability to do that kind of stuff inside of a hyperscale cloud without emulation or without synthetic drivers and that sort of stuff. And so that's where potentially there's a partner out there called FlashGrid that has a solution that actually emulates the missing components. However, it's not supported by Oracle. It's not certified by Oracle inside of Azure. It is certified by Oracle if you run it inside of your own data center. And I can definitely tell you that the folks at FlashGrid know their stuff. They know their stuff. We have them connected with our engineering teams for storage and networking, and we also have them connected with the rest of the Azure Compute family as well. So they're very cool. They've got some stuff going on in test and dev environments inside of Azure with their customers. And if you decided to go into something beyond test and dev, that's between you and FlashGrid and you and Oracle for how it's going to be supported. But that's another separate product. They can do up to 2 nodes or 3 nodes with how they do it. Our solution that is 100% supported is not about high availability. It's about disaster recovery and about having 2 different copies of the database. And that's simply a technology I'm sure you're familiar with, known as DataGuard and possibly Golden Gate. And so that's how we design very large high-end solutions to run for our customers. I was involved in a POC for a particular company that had a 27 terabyte Oracle instance up and running that had 2 DataGuard nodes running an active configuration. And we were able to do a scheduled swapping of the loads between the 2 different nodes. And there was a brownout or a pause, if you will, of the transactions taking place under load of about 25 seconds as it moved over. Does that work for your company? Possibly. It's not the same as doing rack, where there is no interruption or there's simply a brownout and it keeps on going. I will absolutely be transparent about that. But if you can live with that kind of downtime, because it's a scheduled maintenance window for some patching or updating on one side or the other, DataGuard might be the solution that you need to go with. So where can you find some of these references up on Azure and how we do different things? Because I now kind of covered the stuff that runs that's there. That's going to be primarily if you just simply type in Oracle on Azure in your favorite search engine, you'll probably come up with this particular page that was refreshed about, I want to say about 6 months ago, with more accurate and up-to-date content about what we can do on Azure based on customers that are using it right now and that are experiencing success using their Oracle workloads on top of Azure. This links off to a whole bunch of different documentation that's created by our consulting services, by our Azure Cat team, by myself and others who have done and worked with Oracle workloads inside of Azure for some documentation in there as well. And then finally, the last part for just talking about some flexibility on the types of things that run. The Oracle applications that are inside the Azure Marketplace, I literally was the person responsible for making sure these images were created and maintained on a regular basis. And so I can tell you for sure, the latest versions of Oracle Linux, basically the current and N-1 are in there. You can run other ones if you build your own custom images if you wanted to. But the only 2 that we publish inside of the Oracle, the Marketplace that are published are the current version 7.5 and 7.4 currently right now, and 6.10 and 6.9, I do believe. But then on top of that, you have the Oracle database loaded on top of them as well for another option. What I've found most of the customers involved in the projects I was working with, what they did, they chose their own base image, and then they simply logged into the Oracle Technical Network, downloaded the version of software they were allowed to run and download according to their license, and did a manual install. That way they knew they always had the most up-to-date and patched OS. They always had the most up-to-date version of the database software they wanted to run. You're going to find that these ones are going to be lagging behind from security updates perspective and other things just because of the nature of how security updates and images are published. Now, you don't see all the other images of software that I mentioned in the previous slide in here because Oracle has chosen not to create those images. But that doesn't stop you from making your own custom images with that software on top of them. So you're absolutely allowed to go ahead and do that. Microsoft doesn't provide these images. Oracle provides these images, and we make sure that they have all the stuff and technology and skills to be able to create those images on our platform, and they've chosen just to make the database available and the operating system available. Any questions on images? I'm scared to open up for questions because we might get distracted, but okay, we're good. So one of the big compelling reasons to be able to use a cloud infrastructure for this type of workload is because you have the ability to swap and change out and to update and to do all sorts of different stuff with different types of infrastructure, obviously. And so we give you the ability to have absolutely modern cutting edge hardware as the base VM to be able to use. We actually saw that the modern VM sizes with the latest generation Intel chips were providing substantial performance increases over top of Oracle systems that have been running on legacy hardware inside of your data centers for 6, 7, 8 years. It's a no-brainer. Of course it's going to run faster, right? So before you have to go off and make another massive capital expenditure, take a look at being able to use some of these modern Intel architectures that are part of our what we call the V3 family. The DV3s, the ones that most people commonly use. The EV3s, not so much so. They are definitely memory optimized. And then the big ones that we were doing an awful lot of work with was the M series that just came out. If you run this, if you're familiar with Azure, if you run this on a G series, the old-fashioned nickname we used to call the Godzillas, those are not hyper-threaded. You will have a adverse licensing cost on those because it's a 1-to-1 ratio. So if you're using a Godzilla with 64 cores, guess what? You're buying 64 cores of Oracle on top of that guy. So be aware of that when you're talking about calculating your licenses. Always use a V3 of a D version, a V3 of an E version, or an M series machines. Technically as well, the N, which is the GPU accelerated ones, if you wanted to go down that route for some reason, you could use those as well because they are hyper-threaded. So there is, if you simply look on the Azure sizing pages inside of documentation, there is a table that lists them all off, and they list off the number of virtual CPUs to core ratio. Whenever it says 2-to-1, basically, that's when you want to go. Now, it's a database application. Database applications require massive, fast disks with lots of IOPS, fast indexes, being able to do different things. I'm not going to go into how to tune into architect stuff because it's the same principles for what you'd be using on premises to be able to get the maximum performance for caching and for the ways of laying out your log files or redo files and database files and stuff like that. But whenever you're designing this kind of stuff, you're always going to want to be using in production environments, in my opinion, even in proof of concepts, at a minimum, premium disks. You never want to use standard disks, in my personal opinion, just because they're going to be slower. You're not going to have the IOPS you're going to be required, and you're not going to get the performance you're going to want to do for some benchmarking stuff. So go with premium. SSD-based, you can get about 7,500 IOPS per disk. And what you typically would do is you would provision these as simply disks, and then you would use ASM to handle the automated storage management for how they get used on the Oracle layers. So use the Oracle tools to be able to work stuff out. If you have any, what I would used to call a red book or, your step and procedures stuff for how you go off and deploy your images for standard implementations, just use the exact same processes for what you'd be talking about inside of the Azure environment when you're provisioning stuff. And then finally, networking-wise, accelerated networking is available on the latest version of Oracle Linux, obviously as well for other vendors as well, for getting better performance and throughput between your systems. You can use express routes to be able to go off and connect up into your data centers if you wanted to do data transfer. And obviously, if you needed to, with those express routes, you will have site-to-site VPNs that are there. But if you weren't paying attention during Corey Sanders' general session at 2 o'clock on Monday, there's a new thing that just came out. And I love this. I'm a hardware guy. I love this. These ultra premium SSDs that were announced. There literally is now a sub-millisecond access to the data on this disk, as well as the fact that you now have, with a single disk, 80,000 IOPS on a single disk without that network latency. Those are going to be available in the very near future. They're in public preview right now. And then on top of that, there's a new VM size that's going to be coming out later this year that allows you to combine those together in rated form, just like you would otherwise, to be able to make it so that you get even more, like 160,000 IOPS across multiple disks. In the past, you used to have massively large M systems to be able to gang together 32 disks at a time to be able to get this kind of IOPS in the Azure architecture. Now you don't have to. So be aware of those. They'll be coming out in the various different data centers across Azure in the near future. But for now, I would be going with an M series or a D3 series, multiple disks that are premium, and then using automated storage management to be able to go off and to get the maximum IOPS off of it. So obviously, when we're talking about these very large workloads, cost comes into play for being able to handle this. The first thing I want to say is your two areas of cost you're going to want to be able to control are the compute costs, so basically what it costs to be able to run that many CPUs on a box and that much RAM and that much disk space, that sort of stuff. You can reduce your cost on that by basically pre-buying or reserving your instances for a savings. But the place where I found most customers were interested in being able to save money was on the Oracle licensing side. And so when you buy or you lease out or you rent, if you will, an M128 is 128 cores. 128 cores divided by 2 means 64. That's 64 core licenses of Oracle software that you have to purchase. And so that can be quite expensive, potentially. Well, we have what's known as constrained cores, where the VM actually has a reduced number of of CPUs that are exposed to the OS from the hypervisor. And you're able to go and, for instance, get the same performance. In this case, we're using the example of a, can't even see the screen anymore. We're doing a DS14 V2. You can have it constrained down to a 16-core box or have it constrained down to a 4-core box. You get all the same performance of disks, all the same performance of networking and RAM as well. You obviously get a reduced number of CPUs. But you just saved yourself 4 Oracle core licenses right there, just by switching that to a constrained core. So very, very handy to have to be able to use. You still pay the same amount for the box on the CPU side of things, but you're now able to save licensing costs on the Oracle side of things. So constrained CPUs or constrained cores, very, very important. So with all that caveats being said, architectures. The most common architectures that come up for how to properly implement this on top of Azure. We have documentation that goes through how to set this up in a basic form for doing some proof of concepts. We stop at the layer of optimization where it's now down to the Oracle side for how to configure the Oracle software, because it's the same principles that you'd be using as if it was on-prem. But the most common reference architecture that we talk about all the time is your typical 3-layer application that's up and running with a client system talking to a load-balanced bunch of front-end boxes. And from those front-end boxes, they're going to be talking about the application layer down into your database layer. And that's where you have, at a minimum, one Oracle instance configured on one of those boxes. And then you would have a second instance if you wanted to have a layer of disaster recovery capabilities running. Now, this could be running in the same data center. This could be running inside of the same data center in a different zone, because we now have zones inside of Azure, which means it's inside of a building that is separated by at least so many kilometers, but still within the same geographical region, to be able to get a layer of local redundancy that's in there. But then you'd be using, obviously, DataGuard to be able to have your information shipped between the two boxes and then synchronized on the other secondary node that's out there. Now, this is where it took a lot of convincing, because obviously everybody that has Oracle RAC is looking to be able to run it again inside of the Azure environment. But my personal experience has been, with a lot of conversations talking with customers so far, has been, to what extent has it been used in an unplanned nature versus a planned nature? In an unplanned nature, the numbers are relatively small, let's say, for these different companies. For others, it was very, very frequent. And for the ones where it's relatively low, even for the large workloads, as I mentioned. With synthetic workloads being placed on this one example customer that I was involved with that had a 27 terabytes implementation on their box, we were running 40,000 users worth of synthetic load on that box and was able to do a DataGuard transfer between the nodes manually, because it was a scheduled window maintenance we were trying to do. It was literally only unavailable for under 30 seconds, and then it came back and was available on the new node. So for their eyes, it was good enough for the advantages they were going to be able to do by moving this application inside of Azure, and they were willing to live with the risk of not having it highly available because they felt that they had enough highly available protection with the way that we run our data inside of the data centers being replicated on 3 different nodes automatically in the background, with the ability to have our fault zones and our update domains, that sort of stuff. So they felt comfortable with that, but that was a journey to get them there, I'm not going to lie to you. And they felt comfortable enough, it was compelling to be able to go. So this is how primarily most of our customers are running their Oracle databases inside of a production environment on Azure for various different workloads. Now, the neat thing with this also is you can obviously have these logs shipped to any region inside of Azure. It doesn't just have to be in the same data center. You could use DataGuard and have it sent off over to a completely different side of the continent if you wanted to. That would not be a 25-second latency time that's going to be going on because you got the speed of light being involved, but it is possible. And like anything with DataGuard, you're also able to go in and have multiple tiers. You could have the 2 boxes that are there being used primarily for the write type transactions, but then you could have a secondary application that's just hitting the read-only copy in the background for doing reports and stuff like that too. So your choice on how you want to go off and architect that. So as I mentioned, if you haven't done this on Azure before, there are step-by-step guides to be able to go through on the documentation site on docs.microsoft.com that have been written up by different Oracle consultants from partners that have gone in and basically said, here's how I would do this on Azure, literally step by step by step by step, provided you have your own license to get your own licensed software from Oracle to be able to go off and try it out. I guess that's one thing I didn't mention back in the licensing part that I should have mentioned is Azure used to sell Oracle licenses as part of the cost of running the VM back in 2013, 2014, and 2015. We made the choice to stop making that available and instead, because there's so little use of it, instead allow the customers to transfer the licenses up instead as a bring your own licensing mechanism. So that's one of the reasons why we stopped doing it. So you obviously have to, in this environment, have the proper licenses to be able to run DataGuard, Enterprise Configuration Manager, performance analysis, AWR reports, all that sort of stuff. You're going to want to have the proper licensing to be able to go in through and do a proper set of tests for POCs. And obviously with this, the other caveat is you have to fully license your second node, right? DataGuard, you have to fully license the primary and fully license the secondary. So it can become expensive. This is the most common one. The lift and shift reference, basically, again, this destination target is the same for what you'd be doing. But you can use Oracle Data Pump to basically export the metadata and the data itself into multiple disks or into multiple directories on a disk. We're not using any special funky tools. There are migration tools to be able to move Oracle data and workloads by the SQL team into SQL. That's not what this is about. This is about talking about Oracle to Oracle inside of Azure. So this lift and shift reference architecture definitely works for what you want it to do. We've had customers go ahead and use this to be able to connect up to it. In theory, if it's even large enough, you don't have to use the VPN or the express route connectivity. You could use one of our data migration services, drop ship a container to you, the data appliance, Snowball, I think it's called, that we call it internally, and then being able to make it available and go up inside the data center. That's one call if you wanted to for lift and shift reference architecture. Second obvious option as well, if you're interested, is the ability to have a lift and shift architecture. Where's my build? The build didn't work correctly on that. There it is. Going up into blob storage and then have it go off inside of your environments up above. The premium storage slide that I had now currently, this is the current offering for what's publicly available for performance-wise. With how big the disks are and also the number of performance of IOPS that happen to exist. This is currently publicly available right now. It does not include the brand new announcements that came out just on Monday with regards to IOPS, because it ultimately all comes down to IOPS and also comes down to latency. I did not include a slide talking about Oracle RAC architectures from FlashGrid, because ultimately you're going to want to engage and talk with FlashGrid folks about how that works. But essentially, what the essence is, you've got your Oracle Linux flavor on node 1, node 2, whichever happens to be. You install the Oracle FlashGrid node software. They do have a licensed copy and a supported copy inside of Azure Marketplace. It goes in and it builds the required pieces of the shared network between the nodes and also the shared disk between the nodes as well to be able to handle the 2 requirements that are missing for Oracle RAC. And then when that's been established, then you would go through your standard procedures of downloading the bits for being able to run Oracle database, throwing on grid software, throwing on database software and stuff like that to be able to get it up and running basically. So I do encourage you to check that out if you want to try it out and see how it works. The folks over at FlashGrid are quite nice, but be fully aware it is absolutely not supported by Oracle. or certified by Oracle on top of any cloud, but it does work and it is available, and some customers are using it in a test and dev environment, and some of them are using it inside of a production environment too, because they elect to go and to do their own self-support for how that works. Some other tidbits that are there that come up is question-wise with regards to the additional software that people go off and to run. The way I always approach these conversations around EBS, JD Edwards, and other types of architectures, it generally comes down to get your machines and your architecture lined up and decided upon for your back end for those applications, being Oracle database, and get those working and tuned correctly, and then worry about the MTRs, minimum technical requirements, to bring the rest of the software over to be able to run it. And if you've got questions about whether or not it is able to run or not run, the slide that I had at the very beginning, which I'll just pull up again for your reference. If I can hit that, bring this guy up. This one right there. This one talks about specifically if it is able to run on top of Windows Server or Hyper-V. It is able to run on top of Azure, and it's a support statement. However, it is a best effort support when it comes to those secondary or tertiary applications, because we simply meet the MTRs. We do not potentially have an agreement specifically for those that are out there. So be aware for that one there. And then maybe what I'll do is I will get some time left to be able to talk about some stuff. I will be able to take a couple of questions if you're interested. I'll leave the ominous specter of the licensing slide up there in case you're interested. So the mics are live if you did want to go off and ask a question or talk about something about architecture. I will be around. For those of you that are departing quickly without being noticed, evaluations, please don't forget. If you want to see more stuff like this, but more technical depth, put them inside the evals to be able to let us see them. And also, don't forget, 5 is good, 1 is bad. Try to stay in the upper level scales. But any questions from the crowd that people would like to ask, you're welcome to grab a mic, or if you prefer. Oh, we do have a raised hand. Yes, sir, I'll repeat it. Fantastic, great question. The question was, is there a way to be able to back up the database with RMAN and the storage for where that is? There actually is a session here at Microsoft Ignite, I think it's later this week, where the Azure backup team talk about being able to run the Azure backup process to be able to do backups independent of RMAN by simply having some scripts run before and after the backup process, and that's one way that people do it. And then obviously, yes, if you have a manual process that you can kick off using RMAN, you are able to continue to use that. And that is probably the third most popular question that we get when we talk about Oracle, which is what is our backup solution and our backup options for being able to do stuff. If you go to the catalog from your application or from the website and just simply type in Oracle in the search term, you'll see the session from the Azure backup team coming up a little bit later on this week. I don't know the number directly. I apologize. Yeah, right up front here. Oh, do I have to repeat this one? Yeah. Is there ever going to be a managed service for running Oracle on Azure like there is for RDS? And the answer to that one there is I don't know, and I can't comment on that at this point in time. Everything is, as I like to say, here's my PR answer. Everything is possible, and we do whatever is going to be right for our customers. So as more and more people ask for things, we tend to evolve our services as they go. But I'm not aware of any processes at this point in time. Over there in the mic. Yes, sir. Thanks for coming in, folks, by the way. Thanks. Yeah.
Do you have any more information on the constrained vCPU images and how that works?
Okay, good. Any more information on constrained vCPUs? Your best bets for that kind of info is, if I grab this over here, is a document on docs.microsoft.com/virtual machines Windows constrained cores. And literally, the way that this works is, as you know, with virtualization, a machine is simply a configuration file laid on top of the hypervisor, and then the resources are assembled and then exposed to the OS when the OS is booting. And so what we've done is we've made special machine sizes called constrained cores specifically for Oracle workloads and SQL workloads, where it simply constrains the CPUs that are visible. So You get all the same performance for disks and all the same performance for networks and everything else as if you had the full access of all those resources, but you only have, at the virtual layer, so many cores that are visible. So the way that we approach this from an architecture design perspective is using your own knowledge of tuning databases on Oracle on-premises hardware, using AWR reports and analyzing them and changing parameters and running AWR reports again, that sort of stuff. You should be able to figure out the amount of CPU tax you have to have for how many cores to be able to get the workload done. And then you can adjust your VM size. So literally, you can start with an M128, do your performance calculation, see you're only using maybe a quarter of the CPUs you need. You can stop your test and workload. Literally within Azure, if you're at the command line, run a command to resize the VM to a smaller constrained core, and then boot the box back up again and rerun your test to have instantaneous configuration checks. You can't do that on hardware. That's one thing I love about it, to see if it's still going to be able to work. And so this is where we had a number of customers come back and realize that they were able to get away with an M128 constrained down to 32 and get the performance they needed for that database because the workload was not that high. So your mileage may vary. You basically go through, start with the M128, do your AWR report testing and performance and load testing like you normally would, and then see if you can dial back on the number of CPU cores exposed to reduce your licensing obligations. Yeah, this is a rather large, back down, sorry, there you go. This is the doc. This is my friend Cynthia who wrote this doc for how that works. And it's up to date. And so I find that the docs and also the sizing calculator is good to be able to find out where, because these are not available everywhere. The M128s are only available in certain data centers because we roll them out globally. But generally speaking, if there is a constrained core, if there is an M128, we do make constrained cores available inside those different data centers. I've got about 2.5 minutes left for anyone else. The pricing on the constrained cores, yes. The pricing is the exact same as if they're not constrained because you're basically taking the same amount of space on our compute cluster. You're simply cutting back on the CPUs, and so it's the same price. So the compute side is the same price. You make your money back by having to not worry about the licensing side of SQL or the licensing side of Oracle when you're using it. It's as simple as selecting that shape. And so, yes, so when you provision a machine inside of the portal or through the command line or through scripts or through Terraform, whatever you're using to provision your VM architecture, all you do is you choose a different size. So the size name as an example, standard _ M8-2MS. That's telling you that is an M8, not an M128 that's running. And you're looking for the constrained core version that has 2 cores only. And it'll go ahead and provision one for you. So that's basically how the constrained cores work. It's a same family, same architecture, everything else, but the difference is we simply reduce the number of visible cores. Yep, back over here again. Last question before we wrap it up because I got 1 minute and 30 seconds left. Mm-hmm.
What is your recommendation on how to deal with Oracle encryption instead of using Oracle?
And here I thought he was going to give me a nice, easy softball question with 1 minute and 30 seconds left. He's asking about Oracle encryption and having to use HSM and the fact that the Azure ASM doesn't handle or cannot handle and work with the Oracle side of things. I don't have an answer for you on that one there at this point in time to be able to handle how that works. For that one there, I'm going to have to ask, let's connect up. I'll give you my email address, and you can. I'll see if I can find out from the different teams that look after Key Vault, which is our HSM solution, and see what they have for their plans on being able to handle it. How's that? It's the best answer I can give you right now. You got it. So thank you very much for coming. I'm absolutely tickled pink that we had this many people in the room for something talking about Oracle. And so thank you for coming. Hope you enjoy Microsoft tonight. Please don't forget those evals. I appreciate them. Give me some constructive feedback on what's missing and what we can do better the next time around we have this session. Thanks a lot.